calculus time. Today's topic, limits. Now you might be thinking, hey, we've done limits before. They're not that hard. But now, there's a catch. But just in case you're one of those few people at home that are like, wait, excuse me, Mr. Mushfiq, what's a limit? A limit is the value that a function approaches as the input reaches a certain value. And please, call me Mushfiq. Now, let's try some practice. Evaluate this limit right here. 2t squared plus 7t minus 4 divided by 3t plus 12 as t approaches negative 4. Now you might be thinking, Mushfiq, all I have to do is just plug this in. Simple. Then let's plug it in, shall we? 2 times negative 4 squared plus 7 times negative 4 minus 4 divided by 3 times negative 4 plus 12. When we simplify these terms, we get 2 times negative 4 squared equals 32. 7 times negative 4 equals 28. Minus 4 divided by 3 times negative 4, which is negative 12, and plus 12. Now when we simplify all of this, we get 0 divided by 0. No way. We can't divide something by 0. That's impossible. So our friend Hopital made a method to help us solve this problem, and we call it Hopital's rule. Now this rule states that if, when finding a limit, you solve to find an answer that has no real value, find the derivatives of the numerator and denominator functions until you get a real value for the limit. Now you might be thinking, Mushfiq, what do you mean? So we use the quotient rule? No, we do not use the quotient rule. We do not divide the fractions. We don't divide the functions. Instead, we find the derivative of each function individually. F of x, f prime. G of x, g prime x. Now you might be thinking, simple enough, right? Yeah, it's pretty simple. Our first function, f of x, 2 times t squared plus 7t minus 4. The derivative is just 4t plus 7 through power rule and just plain old derivatives. And for g of x, it's the same thing. We just find the derivative and we get the derivative of 3x plus 12 is just 3. Now we're going to evaluate 4t plus 7, because that's our new function, when t is approaching negative 4. So we plug in negative 4 for every t value, and we get 4 times negative 4 plus 7 divided by 3. What's that give us? Negative 9 over 3. But what's that simplify to? Negative 3? No way! Yay, it worked! And we only had to use it once. But just in case you were wondering, if you still can't find a real value, all we have to do is find the derivative again, because you find the derivatives until you get a real value. We don't stop.